Hi, nice to meet you. I'm Sasha. I will talk about what we do. That's the title of the session. I will dive a little bit into the mission and the product we are building, a little bit upfront why we are actually building it. I see already some faces that work in a similar environment, so I think that's that's good to see. I think there's a lot we need to do, all of us, to actually get this done, and then dive also a bit more into how we have set up our technical team to actually achieve it, because there's a lot of technical complexity in building solutions like this. So I will try to give a bit of an overview on how we have accomplished that and some challenges along the way. So first of all, also that might not be completely new for everyone, but every time we talk about the solutions that we build, there is it's a good reminder on why we electrify everything. So I think primary energy sources that we use today are highly costly, and you can see that only by looking at it in more detail. So the way we use energy in the past, we never looked fairly often on where it's coming from. So actually to get it out of some holes in the sea or somewhere in the desert, we need to transport it somewhere. It's highly costly. It's actually damaging our planet. We have to put it into refineries, and only then we get to a secondary energy source that we actually use for mobility to drive our cars, and we use it for our homes to electrify our devices in our homes. We use it for heating. So all of this first step is actually not needed with the modern technology. So we cannot solve it all immediately in one day. It's a very complex and lengthy process. But I think it's a good reminder for all of us to kind of think about it and try to really get as much as possible into that for the next coming years. We as 1,5 are one of those companies doing that also from the ground up. So our story is that we are really doing it end-to-end for our customers initially. So as a residential home customer, you come to 1,5 and we consult you on what is the best setup for your house and for your specific environment. We install heat pumps, we put solar panels on your roof to generate energy, we put batteries in your basement to store that energy, we install wall boxes to charge your electric vehicles. So that's the basic setup you're going to get for a electrified home from 1,5, and everything else we build on top of that environment. And to give you a little bit of a glimpse on what that actually matters, or how much that matters if you electrify a home, it still leads to a problem. So even if everyone has a lot of renewables in their house, there's still a lot of hours of energy consumption that is needed per year in our homes in average. I think that's from Germany. And the sun is not shining all the time, obviously, throughout the day. So you have roughly 2,000 hours of sunshine that you can use for your electrification. There's also wind energy you can use that doesn't have any emissions, and also a free less energy source you can use. Both of those combined still leave a remaining time of the day that we have to supply energy elsewhere to actually get us going. So the only way we can solve that challenge is by putting more intelligence into the systems that we built into our home. So just putting solar panels on our rooftop and batteries in our basement obviously doesn't solve it. So we have to be flexible. We have to move our energy consumption around into the days of the time of the days where we have sunlight and wind energy. So that's a big challenge. That's what we aim for also with the technology we are building. And we have done that already now for 3 years. So we have grown a little in the last couple of years. I'm around for roughly 1.5 years in 1,5. I've been working in this office before at Google for a couple of years, so some familiar faces around. And in the last years, we have expanded into a lot of countries and a lot of locations. So what we do by design is we acquire installation companies around the globe, and really want to be very close to our customers to be also in the installation process, because it's technical components and quite some complexity with it. So we want to be very close to our customers. Therefore, we also have a lot of installers next to our developers that we have in our company. So we are grown to a fairly big size. We are in Australia, in Denmark, in Sweden, Germany, in the Netherlands. So there's a couple of countries. There will be more coming for sure as we expand, because I think also one thing that's obvious It's a large scale effort. We have to attend, all of us, to electrify our homes around the globe. So that it's much more scale in that industry to come. We already have 100,000 plus customers. We do make some revenue with it, thankfully as well, already quite a lot. We do save a lot of CO2 emissions by only putting those devices out there and make them more intelligent. And we connect them to our heartbeat system. So I will be talking more technically around heartbeat, which is our solution that makes our system intelligent. When we connect all of those devices, we have already reached quite a milestone. I think the equivalent of all installations we have is like a third of a nuclear power plant already, like just in the amount of power that is being generated from all of our customers. We strive to have until 2030 the equivalent of 20 plus nuclear power plants. So it gives kind of a perspective on how large we actually want to get in the renewable energy sector. All right, how do we do that? First thing I touched on already, that's the one-stop shop. So we give customers everything they need to have a system in place, from the hardware essence underneath to the software on top. In between, we also built a virtual assembly line. So that's also very much a software engineering task. So if you acquire 75 locations all around the world, they have different tools. If you go into an installation company today, you would be surprised. I mean, digitization is not present everywhere yet in the energy industry for sure, but also in craftsmanship, that it's not that everything is living on modern tools like you would find in this office, for example. So I think there's a lot of work for us to do only on getting our processes streamlined and ensure a high level of quality with every installation we do. And the other thing why this matters a lot on the virtual assembly line, we have to be, with everything we do, less costly than traditional. But otherwise, nobody would do it. If it's very costly to have renewable energy, then if money is not an issue, then you would, and you have the right mindset, you would probably do it, but that still doesn't solve that we have to actually get it done for everyone. So we have to drive our costs and efficiency down as much as we can to actually succeed. And lastly, Heartbeat AI. Everybody puts an AI in their product name. There's some AI in it. I will get to that. We put a software solution on top of that large ecosystem that we have built, so we can steer energy amounts. So before, what I was saying about the remaining hours of the day, that's actually what we do with Heartbeats. We shift energy loads constantly for our customers throughout the day to be most cost effective and have less CO2 emission. Very briefly on the virtual assembly line, I think that's an area that you wouldn't see too much in depth if you are not working in that space. As a software engineering company, you and I will get also to that, how we set up our teams initially. I mean, if you're a software engineer and somebody tells you, please build an app so that an installer on a rooftop can monitor quality of the installation, then you would be like, okay, probably have to get to a rooftop first to actually figure out what I need to do. That's actually what we do. So if you start at 1.5, you're gonna go on some roof initially to actually also learn what it is all about and try to improve constantly on those tools. So we have tools for our installers, we have tools for our salespeople, also to the best consulting for our customers to really make them understand which systems make the most sense for them. We do have also a lot of tools in the backend that help us keep track of our supply chain and make sure that we have the best ecosystem. In addition, so when we talk about the supply chain, we also talk a lot about the hardware we are installing with our customers. So we have managed now, with the growth that we had, to have a very successful relationship with a lot of large hardware manufacturers around the world. We also have our own set of product in hardware that we are building and that we are putting to our customers' homes. Why do we do that? I think the most important piece is that the way hardware is being used is also changing. So in the past, you would get a home battery to your solar panel, and your main goal was to put as much solar power as you can into the battery to use it sometime later of the day. You would have a charge-discharge cycle of like once per day. Nowadays, if we build more fancy products that optimize toward energy price curves at the market, you would want your battery to be actually able to do that multiple times a day with scale, and also to have a certain duration with it, so it lasts for a couple of years. So that kind of change also in the hardware manufacturing is something we discuss also very closely with our partners to make sure the products are actually also evolving with us when with software. What do we do? Initially, if you get our product, you basically get a solar panel, heat pump, battery. You immediately have then our heartbeat installed in your home as well, and you have an app where you can interact with your assets. You can see what it does, what is happening in your house. It optimizes also. I think optimization in its easiest form. Solar power gets stored battery if you're not using it, or if you're using it to charge your car and you have even more power, it gets pushed into your battery. So that kind of optimization locally in your home is already done from the beginning by design. What we then do in addition, and I think that really does the trick, is we connect also to another level of complexity when it comes to data. We connect to the energy market. So we put an energy tariff on top of it, Strom hoodie right there. So energy tariffs, dynamic energy tariffs are being developed right now in a lot of companies. I think there's definitely a need for it, that we are going away from having an energy bill and an energy distribution from an estimated historical point of view on what a household should be using, towards something where we can actually follow the consumption of the customer and really put that amount of energy into a home. That is what we do. In Germany, you have a particular challenge with it because 1% of the houses have a smart meter, the rest doesn't. So part of what we do when we initially come to customers, we put those things into those homes, because otherwise the whole thing really does not work. In other countries where we are active, there is a lot of smart meters, so that we do the same thing, but we have less of an effort initially. But that's part of the story. You get a 1.5 energy contract, so therefore we buy energy for you. So we are an energy utility now. I wouldn't have thought we would do that initially when I started, but it's actually really necessary to do that end to end. Otherwise, and it's especially necessary to connect it also with your hardware. If you just get an energy tariff, am I already at 30 minutes?
Yeah, you're already at 15.
Yeah.
Yeah. It's now 30 minutes left.
Okay. There's a lot more to come. Exactly. So you want to connect also to your hardware, because otherwise you consume energy when it might be less cost efficient from the market, but you don't know actually how much you are consuming in your household, for example. You want to be also accordingly. And you can also do fancy stuff with it. VPP, that's virtual power plant is the name for it. So you can, for example, offer for grid stability services also to our customers. So if the network is very full, you have a lot of congestion, and the network operators struggle in various countries really already today very hard. So you can offer user residential home batteries also to participate in that market, and power gets pushed into the batteries if the signal arises, to take some of the load off the grid. So it's also a fairly complicated technical product to build. It's very much also hardware related, but you can easily put that as a software product on top of what we have built underneath the hardware. No, in Germany we don't. But can we do questions at the end, please? Yeah, sure. All right. How does it look like today if you do that kind of stuff? You asked already the country-specific questions. That is from the Netherlands. Why? Because in the Netherlands you can also discharge into the grid. In Germany, it's not allowed yet. It should be allowed, hopefully, at some point, because it gives you a lot of flexibility how you deal with energy. What I said at the beginning, the more flexibility, the better on how energy is getting distributed. So throughout the day, you can see also in that chart, we charge the batteries when the price is, for example, very low. We discharge it into the grid when the price is high, and if it's not being used. So some of the forecasting that we do in our systems give us actually the ability to see, okay, in the morning there's sun coming, so we wouldn't have to charge use the battery power, and we can actually discharge it into the grid because we have solar energy power coming that can be used in the household. So that kind of decisions you constantly take throughout the day for thousands of households. So that's basically what helps you on a large scale to build a very effective system. For customers overall, that raises sometimes also a lot of questions. So if you are a customer and it's like, okay, energy price was 0, why did you fully charge the battery? Then you could answer them. I think that's what we do also very much initially, like, hey, we didn't charge it fully because there is sun coming, and then your battery gets charged from your rooftop, so it makes more sense to charge it from there. That kind of question, that kind of explanation towards customers is super important, because nobody actually had a lot to do with it. So if you're very nerdy about that kind of stuff, you do love to look at graphs like this. The average people don't. So if you want to use your energy system, and it would be nice if somebody explains to you how it actually looks like. That's what we do with our apps. So our heartbeat helper actually tells you, hey, that's what your system is doing throughout the day. That's why we have charge your battery. That's from the grid. That's why we have put the solar energy into your battery, and so on and so forth. So it's a little bit more context for our customers behind. What does it mean for engineering? That's one of the tricky parts initially when we started and built those systems, and that's probably true for every startup. You have a couple of engineers and you put them in front of a problem and they try to figure out what we need to build. They have the technical skill to build it. They have to somehow get the infrastructure ready, put it on top of it, and they do it all together. That leads at some point to a lot of bottlenecks. So the more you scale and the faster you want to innovate, you have to free up some time from the people in order to do less infrastructure, do more code, get more knowledge into the area they're working in. In the energy space, especially if you're building products like this that are technically very specific, we needed to free up a lot of time to inject knowledge into our software engineering. There is no way you could just put a person as a product owner in front of it that has it all figured out and that engineers exactly what to do. In that space, there is a lot of innovation and collaboration of the engineering needed with some knowledge to build products like this properly. That's what we have done over the last year very extensively. We have been hiring a lot. We've been growing very fast. So that's an art by itself to actually get teams going and not slowing them down. We have also divided our responsibilities in the team. So we have built a platform team that is very much also working with our friends from Google over here. They have built a data platform together. We have built a developer platform. We try to automate as much as possible our infrastructure. One reason why software engineers in one of our dedicated development teams don't have to worry too much about infrastructure decisions to be taken. So I think there's a couple of ways to achieve that, but we have chosen that model to do so. We have site reliability engineers, security engineers that constantly enable also software engineers while we are developing software. The bigger we grow, the more security becomes relevant, for example. So we are already aware that that's the big one to have an eye on how we build actually our infrastructure and how much you can actually interact with it as an individual software engineer and what your guardrails are when you do development on a platform like this. And on top of it, we have built stream-aligned teams. That was also a hard one initially if you have cross-functional teams. So also initially when you hire, you have a lot of focus on the domain you have technical knowledge in. So as people working in your front end, you kind of started to build an app, build an IoT system, you build all those things and people have their dedicated area of knowledge. That leads very often and very quickly still to be fragmented and siloed approaches that you have to glue together later on again. So we have put them a lot into streamlined teams so that the people building the app are working side by side very closely also with people building the underlying systems. We have a lot of those teams. There's a flexibility also in those teams to change when we introduce new products. With that model, we also put a lot of knowledge into those teams. The teams have the responsibilities on their own to build their services, to run them, to monitor those. Monitoring is a big one in that environment. I will get to that. I think the biggest amount of effort in engineering with products like this you spend with having proper monitoring solutions in place, actually. And we have dedicated data science and hardware engineering teams as well. I will get to that also. They usually don't fit in a model like this, and they kind of on the side, especially if you are a hardware lab engineer, then you kind of like, hey, you do it retro and software stuff. I kind of put tables together, but then we integrated them very nicely into our team. So you would see our software teams working very closely also with our hardware engineers to make sure when we connect devices, we get the right data out of those. When we steer those devices properly, they accept the commands, and we have the monitoring of them. Some KPIs. I think that's also not too much of a rocket science. If you have a good growth and build platform teams, that's what we measure also in our engineering teams to see that we actually get better in what we do. So when we grow and put teams in place that focus only on platform topics, we do want to expect that we get more cost effective, that we get much faster in our deployment cycles. That one, if you look at it from the beginning of the year, we have really achieved. So we, in our individual teams, we get really fast in rolling out new software, which is super important. So in that space, you have to innovate all the time to keep up with the changes that are coming your way. We also need to onboard quickly. As I said, we have grown from 10 to over 150 engineers in our team in a year. So onboarding time has to be very minimal for engineers to actually get going. And lastly, also infrastructure deployment. I think that speaks for itself. That's a no-brainer in a modern tech environment, able to spin up infrastructure very quickly. Yeah, fast pace and advanced tech hitting the energy market. I think that's one of the findings initially. Probably some folks in the room would agree if they work in that environment. It's not as tech heavy as you would expect initially. If you need to call an API in the energy environment to, I don't know, get your grid costs to make sure they are also part of the optimization of your energy contract, you might get a CSV file. And so that kind of stuff you really have to account for in multiple ways. If you're working across multiple countries, those interfaces look differently. The partners you work with are very different. So we have actually built a energy service team that does only that. They monitor a lot the interfaces we have with parties we are working with. We actually procure energy from the energy market, so we have to do a lot of monitoring around that. We do it accurately. We have KPIs on how to get better, and with our forecast that we do. So that kind of stuff requires a lot of monitoring and a lot of good engineering and at those interfaces. That has cost us initially a lot of time. As I said, we didn't set out initially to actually do that, so we were thrown into that's what we need to do to get this whole thing going. And then our engineering team evolved into building actually an energy utility service behind the scenes. It's not as prominent as an app. I put a nice picture of our dark mode, so innovation speed. So software developers on an app, once they have really gained speed and are productive, it takes them, I think it took them 3 days to turn the whole thing into dark mode. And they were like, wow, awesome. So I think that's that kind of speed we need in all of our teams. So we also getting there on the energy side. But I think it's nice to see that we have those bits and pieces now. They nicely fall together. The hardware integration and the lab engineering. So I think that one is also important for us. It kind of tend to forget it if you assume there's all smart meters around and we can just put software on top of it, and we have a lot of data and we optimize everything and then we are golden. Half the time that doesn't really work. Smart meters don't give you the data that you need. You need to get them elsewhere. You need to really work closely with the interfaces of those machines you put into homes. So that's one of the big advantages we also have, that we are very close with the installers, putting those with those branches and our tech heroes. So that's technical people on the ground in our branches. So in Germany we have 40 branches all around the country. There's technical people, so we sync with them a lot. We have a large lab here in our office in Berlin, where we gather also together with them to figure out, is everything working as expected. We invite our manufacturers, our OEMs to come on site. They have software releases also constantly that introduce new data points and so on and so forth. So that kind of stuff we need to constantly implement into the solution that we're building to make sure it is actually reliable, it's fast, and it's providing the right set of data. If we want to do new stuff, for example, like I said, with the frequency market before, that's something we have a lot of engineering capacity that needs to go into hardware manufacturing and to collaboration with hardware engineers. So that's why we have also built the lab in Berlin to put our software engineers very close to the hardware engineers. Feel free to come by. It's a showroom as well. One thing we do very nicely is put showrooms all over the globe where you can actually walk into and touch and feel this energy stuff that feels a little bit fuzzy sometimes if it's not nicely put in front of you. So otherwise, that's if you go into a showroom and you have the experience on, okay, this is how energy is flowing in my house when I have the app in my hands, then customers usually are more inclined to, okay, I want to do that change instead of getting it somewhere where I don't know where it's actually coming from. Yeah, architecture slide. You have to do that somehow. I just put it up there and don't want to go into detail because I probably will run out of time. It illustrates what I said before. We do need to build a base with our hardware devices on at the bottom where all the data can be aggregated. We aggregate them in various levels. It makes a lot of sense to aggregate them on the site in the house so that all assets make up an entire house. So we can steer and optimize it accordingly, connect it with our energy contract to the energy market. We can also aggregate them even further on a pool level to do other stuff with it. So that's intraday might be something some of you have heard of. So if you are procuring energy from the market for our customers with a forecast and the forecast is off, we also have mechanisms in place throughout the day to make it more accurate and really procure the right amounts of energy for our customers and get to power up with it. If we do that properly, then you see the result in our app. So that's what I said right at the beginning. If we manage to connect with our assets in the optimization and we are able to steer them accordingly, then we can really shift the load on, for example, the easiest one to grasp for everyone is an EV. If you plug it in, it's in your home, you don't want to make it charge right away. You do want to make it charge when you know the price is super low, or you have a lot of solar energy being stored at some point of the day that you don't need for anything else, because we also know what the other loads in the household are. That's where we want to shift all of those loads. That's what we want to show to our customers. In the end, that is also what brings your energy price down. So what I said, or what our mission statement is at the beginning, comes down to an energy price. That's also how we make it very tangible for our customers. We want to get it down to zero as much as we can. And there's times of the year, obviously, it's very lucky to have a presentation right after summer. To get energy prices down in summer is really doable. You can see that. So it's actually real data. So it's not fake. That's customer data from our systems. You have a lot of sun energy throughout the summer periods. You get less energy from the grid, so you achieve very low energy prices. The good thing about the winter months coming is you have less energy from what you generate from your home. You procure more from the grid, but then you can actually do more optimization. If you look into the heartbeat helper that I showed you before, in winter months, it's much fuller telling you what the system is doing for you in order to keep your energy price low and shift the load around the household. Summertimes, it's really mostly optimizing on the sun and wind periods of the day. And with that, I didn't see a sign for time, but I think I'm pretty good with it. That's the picture when I started at the company. I hate it. I was way too warm. It was raining. I was running there. I got a hoodie and I took a picture. It's everywhere. Thank you.
Thank you so much, Sasha, for sharing. Is there any questions from the audience? We have a microphone here, so we have like 10 more minutes for questions.
Thank you. Is the microphone? Hi. Okay. Thank you very much. I think great presentation, and also I really like the company. I think also super nice to have this company in Germany and export it around the globe. I think your CEO, Philipp Schröder, he's also doing a great job, but also good marketing. And it always feels like he's promising a lot and also delivering. I think in 3 years, it's a great product. But I always feel like you as a product and tech team, you must feel under such a pressure because sometimes maybe he learned from Elon Musk. So maybe he's like over-promising a bit and you need to deliver. How do you deal with that in your team that they don't burn out every day?
That's a good one. I actually like it about Philip. So I think he's very reasonable also in a way on what we can over promise to ourselves initially. I mean, you should aim to a certain level to actually get there. I think that's kind of a rule we give for ourselves. If it's completely not achievable, also from a technical point of view, we can be very vocal about it, and then we wouldn't also push for it. So I think there is also a difference in promising something that is really hard to achieve, and we really have to push to get there as a tech team. But we wouldn't go out with something that we as a tech team don't believe we can actually do. So I think there's one difference. We talk about it a lot. So we do have also with Philip on a bi-weekly basis. We go quite deep also on our development plans. So that's a good exchange. Getting it down to the teams is another one because it still feels a lot, right? So you have a lot of timelines that you want to achieve, especially technically. The one product we have built now that is constantly evolving. That's one area. The other angle we want to scale internationally, and that is unfortunately in the energy sector, it's not always exactly the same product. So as I said, there's different partners. The energy market is working differently, so you have to kind of adapt. Some parts of it we have built now in a way that we can easily adapt them to another market, but that adds a lot of complexity to the overall discussion. So sometimes we also go back with the timelines. You see that a lot, especially when we roll out into markets, that we move a little bit our timelines on when we get there, when we figure out, okay, that's actually more complicated than we initially thought. So that happens. But so far, you're right. We kind of achieved most of what we said we would be doing. And the team so far, I think one big one is that the engineers in that area are very much purpose-driven as well. So they do like to put a lot of effort to get this stuff going. So I think there's also a healthy culture of people really wanting to get this stuff.
Yeah, thanks for the presentation. Really nice. Yeah, very detailed as well. I really like your kind of architecture.
I try to put something.
So yeah, my question is around some of the parts you mentioned in your presentation around discharging batteries, and that it's not allowed in Germany, but allowed in other countries, right? So what are your challenges there in terms of, the process of making that happen? So I imagine you guys want to be able to discharge batteries to the energy grid here in Germany too, right? Yeah, how do you deal with that, and what are you doing towards that right now? And maybe another related question is like, how do you do user acquisition, right? How do you get to the customers? Like you mentioned also that you have the showrooms, but is there any other types of user acquisition that you implement in your company? And yeah, thanks.
Let me start with that one right away. There's a couple of channels. I mean, we have sales and teams that also reach out actively to our customers. We have a good referral program. I mean, the better, that's the best sales channel anyway. If the product is nice and people refer it, so we have in the app built in a nice referral program where you can also earn credits with it for yourself. That is a big driver. So kind of one of the main channels we have. And the sales teams also depend on the country. I would argue there's some countries that are more open to online sales teams, others have more need for a field sales teams because it's a very emotional topic also to be on site with customers. I think that's where we put the other Sasha in the company that is doing our sales lead. He's putting a lot of effort into building sales teams together that can be very close to our customers in the country. So showrooms are one thing to get them in. We do also do events and try to be very close because we have to do a lot of education initially also to convince customers. It's a very pricey product you sell in the end that is lasting for 25 plus years. Customers are very mindful in the purchasing decision. That's one thing. The other one was about batteries, discharging to the grid. Yeah, I mean, technically we try to build, or we build it in a way that we can do it, and we have to be very closely looking into regulations for each country. So there's people from our product teams doing that on when can we do what. Stuff changes all the time as well. If you have some countries, so Sweden is a very good example for it, the regulations and tax authorities, subsidies and stuff like this changes like on a half-year basis all the time, and you kind of adapt your product around it because then customers might want to shift that or the other direction. For us, important is not to confuse even more. So because there's a lot of also startups out there that are like, hey, get a battery, get this app, and then you're awesome, you earn a lot of money. We try to build a heartbeat. Like I said, it's a very pricey effort to build those assets into your home, and then you get Heartbeat as a solution that can actually evolve with you over time, so that you can get into a new product into the market without adding new components to it. So yeah, we try to make sure from our product team that we are ahead of the curve. Sometimes you figure out, oh shit, we have to build something differently now. But yeah, that's part of the game, being very flexible and fast.
Just quickly, so you kind of just go with the regulations. Your company is not doing any kind of lobbying or other type of, close governmental work to implement this change. That was more.
Okay. Yeah, we do as well. Yes, I mean we have people also around Philip that do a lot of governmental lobbying work, I would call it. So I'm not sure how that actually works. I'm the tech guy, but we do that as well.
Yeah, thank you for the presentation. You said that at the moment you're at half a nuclear power plant or something, but you're aiming to scale for multiple, like the power of multiple power plants, actual power plants. At that point, I imagine right now you're mainly focusing on individual homes, like getting the most out of the whole thing for this one home. But if if your system connected to, well, Tesla calls it a virtual power plant, in the size of multiple actual power plants, at some point it might be necessary to not only look at the individual homes, but also to look at the whole thing in terms of you forecast this battery will probably be charged to that amount in that region, while this battery will a little bit less. So you have way more optimization or like knobs to tweak. What do you think would have to change, for example, in your overall setup technically, mostly obviously this tech conference, so technically rather than, yeah, that's how it is today.
Yeah, good question. We're getting deep here. Not too much from a technical point of view to actually the pooling concept I showed before on the layers. So we are actually able to group pools of batteries together. The difference, I would argue, on how we build virtual power plants is compared to an OEM like Tesla and Sonnen and others are doing that as well. Utility companies also do that. They put a large group of assets together on an aggregated pool level to optimize and steer flexibilities. If we do that for an individual house with our customers, we might not be as efficient initially, because if you have one house and you have some flexibilities, you use an intermediate market and trade for it on that. If you offer the flexibility, we also will create pools. We can do that. We can offer that to our customers. Is that the most economical thing to do? In some markets, it is right now. That's why we are offering it. So you create a pool of those additional flexibilities and you can offer. In other markets, it might not be, or it will turn down because the TSOs don't want residential home batteries to participate in it even more. Then you drop down back to, okay, let's then optimize towards a head price curve again. So for us, that flexibility is way more important than actually build one product that fits it all and then build another one the next day. Does that answer the question?
Yeah.
Yeah. Okay. Can talk about after.
Okay. My name is Bondarenko, firma Confite. I have two questions. First one, you have a great mission and very complex topic. Are you able as a private company to solve this problem? Because you need a big players like government, like energy manufacturers, and without them you cannot do that. And the second question is, I understood you managed it, different energy sources, and you are able to offer lower prices, but you have two points. You have customers, users, and you have producers of energy. And if you amount of customers growing, you will be able to offer these lower prices. And how you want to solve these problems in the future, because you need to manage two parts.
Yeah.
Thank you.
I haven't answered yet.
Thank you for sharing.
Customers or consumers, customers are at the same time nowadays also producers. I think that's one of the key points of it, because you produce your own energy. That's one piece of the entire puzzle, because we shift from centralized energy production from big power plants to decentralized, where everybody also feeds in power back into the grid. So in order to get the best price possible for yourself, you use your own power and then you participate from the market. The bigger it grows, we will definitely annoy also a lot of the companies all together that are doing stuff like this, some large utilities that are producing energy. We are not big enough yet collectively, I think, in the residential home space to shift the attention entirely. But I think there is a big chance for us also in that market that prices overall will go down, because there's way more customer and installation like this coming to the market. And I think the steering of those assets is what is actually what large utilities will focus on a lot going forward. So you see that already when you look into the network operators. They need to figure out how to deal with additional load coming into the network from the PV panels all around. There is much more EVs coming in every country, much more heat pumps. You have some countries that already have a lot of heat pumps and EVs, and the net is super full and congested. So you can build business models around operating a network. There's variable grid fees coming. So that kind of stuff will take a lot of effort also from energy companies. It might drive prices sometimes up, hopefully eventually down. And we will always, I mean, that's the beauty of being a startup. You push against it, right? You kind of try to not have the prices set as they used to be, but really often cheaper alternatives. So the effective energy price is a way of us making it transparent, so that you can actually see how is those, because for now you wouldn't know, right? You look at your energy bill, it's very confusing. So you actually have no clue where it's coming from. That's what we can force. The bigger we all grow in that space, also that there's no transparency on all that.
One last question. Time for one last question. I think you were the first one, so happy to hear your question. And then afterwards, I think you also feel free to chat to Sasha on the conference. So yeah, happy to hear that question.
Yes, I think your product is probably mostly for the countryside, like you need solar, heat pump, maybe storage. Difficult to have in a flat in Berlin. And probably most of your like tech product and design team lives in the city. You already touched on it, like you said, you try to educate your developers and you have like the showroom. But how do you do it exactly? You have like online courses, or you rent a bus and bring everyone to a house and show them?
Yeah, it's true. I mean, that we all have parents. My mother, like being 1.5 years in that company, she lately told me about that. A co-worker of hers has some new app, and she can see how that energy prices changed. And I was like, Mom, that's what I cannot do that. Yeah, so it sometimes takes a little longer to actually educate also all around us, but also in our teams. I think for the developers, yes, we do that. If you start, you get an onboarding, you get to a site, you get a look and feel. You have luckily also a lot of people around in that company that are very deep in that renewable energy space you can talk to on a daily basis, and it's important to do that initially. So the bigger we grow, the more we have like energy enablement sessions. We have product owners that are also coming from the energy sector that we have sessions, pairing sessions with during the week. So that we actually get as much knowledge as possible. Sometimes maybe not too much, because some stuff also has been built way too complicated. So it's good to have a fresh eye sometimes on various topics. But yeah, we educate ourselves, but also the market, also the partners we work with. You can already see some of those relationships have gotten much better. Like there is so much knowledge exchange and engineering exchange that also some of the partners that have been around forever in that space start to get better when it comes to engineering capability as well, which is in the end what we also need at time for the thing to work.